Good morning. My name is Ben Azvine, and I want to talk to you about AI and security. I want to share with you some of our own research in the area of how AI and security interact with each other. And I want to talk to you about some of the examples that we've developed in our labs to show the benefit of AI for security. So let me first address the question of why use AI in security. Well, the landscape for threats in security is very dynamic, and we're seeing more and more sophisticated attacks on our network. Currently, we deal with around 4,000 cyber attacks a day. Also, we're seeing much more sophisticated technologies being used to launch cyber attacks. And this points to the fact that our adversaries, the bad guys, are getting highly organized. And this leads to this schematic that I have on the screen, which is, we're seeing the old weapons like viruses and worms combined with the new weapons like spyware and ransomware and rootkits and advanced persistent threats. And that gives the full picture of why we're seeing so many cyber attacks on our network every day. The second reason why we need better security solutions using AI is that the adoption of new technology, the rate of adoption of new technology is accelerating, and this leads to exposure to all kinds of threats due to bad architectures or bad implementation choices and so on. I've listed 4 technologies here that could have a positive or a negative impact on security. I don't have time to go through all of these, but these are the ones that currently we're focusing on in terms of how to enhance security and what could be quite disruptive to the cybersecurity landscape in the future. I'm going to talk a lot about AI today, and I'm going to focus more on the positive aspects of how AI can help security. So when you talk about AI and security, you've got to really be thinking about these 4 quadrants that I have here. I'm going to spend a lot of time on the top left quadrant, which is cognitive cybersecurity. And this is where AI is used to enhance the level of security. But our research also focuses on the other quadrants. And very briefly, I want to mention them because they're quite important. Understanding them actually is going to help us build better AI-enabled security systems. So weaponization of AI is something that we see on the side of our adversaries and the bad guys. So a good example of that is fake everything, detection of fake news, fake identities, fake profiles, and so on. That is very accessible and cheap these days due to the use of AI. Vulnerabilities of AI systems are well documented. A lot of machine learning systems suffer from things like poisoning attacks. That is, poisoning the data that are used to train them in order to generate behavior in operations that are undesirable or catastrophic. Privacy and protection of data that is used in machine learning systems is an important topic for us. And in there, our research is all about, how do we analyze encrypted data? How do we preserve the privacy of confidential information and yet be able to get useful information out of it for the purpose of increasing the level of security in our organization. But let me now focus on cognitive cyber defense. So let's say that we want to use deep networks, machine learning systems, AI in our operations. What are the things that we should be aware of before we do so? Well, first thing is that high levels of accuracy does not mean that systems are suitable to be used in the security apparatus, if you like. A lot of deep networks are statistically impressive, but even the low error rates that they offer, like 1%, 2%, and so on, make them unsuitable for use within security, mainly because the consequences or the actions that we take in security are quite significant, and therefore we can't be happy with 98%, 99% accuracy. Another issue that we're looking at is the fact that although many of the current AI systems are very useful, but they still nowhere near the level of capabilities of humans, and they make simple mistakes mainly because they don't have common sense knowledge. They don't perform in the same way. They don't have the same cognitive capabilities of humans. And so if you are going to use security, AI in your security, then you need to be aware of the fact that the level of expectation that you have has to be matched with the capabilities of these AI. So this is a simple example of a very rudimentary mistake by a sophisticated speech recognition system like Siri, for example. So our view of how AI can be used within security is very much along the lines of intelligence augmentation. This is where we use AI systems for rapidly learning patterns or anomalies in data, but then use human knowledge where the AI system's limitations come in. So this is what we call intelligence augmentation. And to do this, we've developed very, very sophisticated interfaces using visualization of data to allow interaction between the AI systems and humans. So we've taken this idea of intelligence augmentation and developed a number of application areas where we're using AI to enhance our security systems. And here's a list of some of these application areas. We're using AI for anomaly detection in log data. We're using it for threat detection to classify threats, for example. We're using visual analytics and unsupervised learning like clustering techniques. We're using it for threat modeling and simulation. And we've just started doing some work around using machine learning in automated response systems. So let me show you some of these systems. This is a visual analytics application called Saturn that we've developed to enable security analysts to investigate incidents. The idea of the system is to have a very simple front end, a web-based front end, where we represent everything in terms of good versus bad. So in this case, we're looking at a botnet attack. The red dots on the left-hand side are the sources of attacks, sources of malware, and the green dots are the destinations or our servers. Now, the idea here is to have this kind of intuitive environment for doing investigations. And what is happening on the right-hand side is that there's an unsupervised learning system, a clustering system that, based on what the analyst does on the left-hand side, organizes groupings of data for either similar or dissimilar cases. And in this case, in fact, you see some clusters on the right-hand side. The system doesn't tell you what they are, it just tells you that they're similar. But actually what leads to the finding of the botnets is the outliers, is the stuff that hasn't been clustered. So this bit at the bottom left-hand side is the outliers, and this investigation leads to the identification of the vulnerable machines and the sources of the attacks and the subsequent removal of the vulnerabilities and blacklisting of the sources. This application is a graph analytics application called Nexus. Its objective is to represent relationships in the data in terms of graphs. And then on top of that, we use anomaly detection algorithms to highlight anomalous communication between two machines, for example, in this case. And what you can see is that already this graph is a much scaled down version of what we see on the network. So that's the job of AI filters. And then when you actually look at the individual graphs, some of them are highlighted in red, which shows anomalous behavior. And in here, we're using a variety of algorithms and techniques for analyzing very large scale network logs. This is another application of anomaly detection, but in this case, we are using a deep neural network to understand what normal pattern of behavior in our network looks like. And the way this interface works is that the closer data is to the center of this orange blob, the more normal the behavior of the network is. And what happens here is that when we train the network and use it with real network data, it will give us anomalies that are represented here by spikes coming out of this central blob. And these anomalies, by some training, will be available to the analyst to select for further investigation. In fact, that's what you see now. The analyst, using her knowledge, selects a small number of these anomalies to further investigate. Once the analyst decides that she has selected enough points, then that is feedback to the system, which will give more information about those anomalies. What we see here is that there are two groups of data that represent those anomalies selected. One is an orange blob on the top left. Now, the analyst has decided that's anomalous but not malicious, but the blue blob at the bottom was something that caught the analyst's attention. The analyst selected those points, and now the system has come back and identified that this is a botnet. This is the source of the botnet. Now, the important thing about this system is that it's using very low-level data from the network, and therefore we use this as a kind of early warning system to start the process of investigation. Once something is identified as anomalous in this system, then that data is taken into the previous system, a visual analytics system called Saturn, and the data is then combined with data from external sources to gather more evidence about whether this is a real attack of high impact or not. This is another example where we're using similar clustering techniques for identifying anomalous behavior. In this case, it's a blockchain monitoring system, and we're using AI to reduce the volume of data of transactions. In fact, this data refers to a set of transactions after a ransomware attack. And what the tool has identified for us is a small number of wallets that have transactions, unusual transactions, very close to payment of ransomware. And this investigation was, in fact, a real investigation and was carried out with in partnership with law enforcement agencies. And the value of using AI here was to rapidly identify those wallets and then link them to wallets that belong to gangs or criminals out there. And the total result of this, the use of this tool, was that we reduced significantly the amount of time it takes to actually identify who's behind the ransomware attack. We're also looking at how to respond to future attacks in an automated fashion. So this application is looking at a very simple software-defined network, and the first job of this application is to identify that there are anomalies, or there are anomalous behavior in the network. And what you see here is that on the right hand side you've got the internet gateway. The application has identified the sort of malicious sources, and these malicious sources have infiltrated part of that network, and in fact installed some malware on one of the end devices. Once this device is part of the SDN network, it can launch a repeated request for information from the controller, and thereby create a DDoS attack. And so the first job of the system is to highlight that an SDN network is under attack, where the attack is coming from, where it's going to, for the analyst to be able to respond to that. So once an SDN network attack has been identified, clearly there are a number of actions that the analyst could take, and one of the projects we're working on, called Inflame, is around creating a simulation environment where we can simulate various responses to an attack and learn from those responses. And what is possible in this system is to artificially introduce a vulnerability into the network, and then see the impact of that on the performance of the network. And once we have a model of a network, this is a very simple model of an SDN network, then we could have a deep network observing the actions and the consequences of those actions in terms of the performance and security of the network. And we then have a reinforcement learning algorithm to reward those actions that lead to a better security, and punish those actions that lead to worse security. And through many thousands of simulations, the system learns what are the best possible actions, and the idea here is to then either fully automate these actions, or more likely offer these actions to network security operators, who then will have a very small number of actions to take, knowing that these are actions that have worked before and have had optimal impact. Finally, I want to talk about how we are bringing all of these together in the future. So this is a virtual security operations center in which all of our AI tools will be available to distributed teams around the world. The idea is that this technology allows us to build a very sophisticated combination of the tools I showed you. In the future, the ideal time to build a custom-made environment for a specific investigation is under an hour. The system is very, very intuitive. You could train people to use it in very little time, and it can be used both in operation but also for training, for scenarios that obviously you wouldn't wish to happen to your network. And the idea is that anyone with a headset, Oculus Rift headset, could join from anywhere in the world, be part of the investigation team, and once the investigation is over, you could delete the whole system and create a new one. So in conclusion, the answer to the question of AI and security, Ironman or Terminator, is definitely Ironman. We want to utilize AI as much as possible to enhance the speed and knowledge and capabilities of human operators to fight the most serious type of attacks in the future. Thank you for your attention, and I'm happy to answer any questions.